continue our discussion on pumping lemma. Our next language for discussion is set of strings over 0, 1 such that x has equal number of zeros and ones. So languages like a power n, b power n, or languages like b power n, a power n, and all these are special cases of this language. So this one says it is equal number of zeros and ones. It can even be like 0, 0, 1, 1, 0, 0, 1, 1. And in terms of a and b, it is like a. In fact, I should write this as 0 power n, 1 power n, 1 power n, 0 power n. Okay, so things like this will not come under this or this. So this is a generalized form. But these two are special cases. So that's very important. But we know these two are not regular. So that itself gives you a message. So here is a language which is not regular and it has a special case of this. Then can I simply mimic this proof to say that this language is not regular? Answer is yes. Because pumping lemma says choose W such that cardinality of W is at least n. Okay, so the choice of W is with you. Okay, and so let me choose W to be this. So W to be 0 power n, 1 power n, or 1 power n, 0 power n. Anything is fine. So the W that we choose, it should depend on n. That much is clear. Choice of W is with us. Then for this W, you come up with any decomposition. So for all U, for all V, for all Z, such that W is UV Z with a constraint that V is at least 1 and UV is at most n. With this we will produce a string which is not in this language. Now this string has got equal number of zeros and ones. Now it is clear that 0 power n, 1 power n, UV is concentrated only on this part because of this condition, which means V contains only zeros. And we do not know how many, so it is 0 power n minus k times 0 power k times 1 power n, where k is at least 1. Now here is a string W prime equals 0 power n minus k, 0 power k to the power I, 1 power n. Now choose I equals 0. We get to see that 0 power n minus k times 1 power n is not part of the language. This implies that L is not regular. Okay, so one can see that a subset is not regular, therefore a superset is not. So now, because the proof only demands that you choose a string, there exists W, there exists I, and the one that we do not have control is the decomposition part, which is why we do not assume anything about how the decomposition is done. We say whatever may be the decomposition, there exists I such that here is a string which is not part of the language. Okay, and this gives you a larger message saying a subset is not regular therefore a superset. It's superset. Okay, so now similar proof can be given if you start with 1 power n, 0 power n. Okay, and this itself can be used as a framework in solving many other related problems. For example, this is one, and let's look at this problem. So the language is set of strings respecting the palindrome property. So set of palindromes. So L prime is set of strings over 0, 1 such that x is a palindrome. So which means it reads the same in forward direction as well as in reverse direction. That is a palindrome. A string that reads the same, for example 0 power n, 0 power n. If you read from left to right and right to left, it reads the same. 0 power n, 1, 0 power n. And again, if you read from left as well as right, you read the same thing. So now we want to show that this one is not regular. What we will do, we have to choose an appropriate string. That's where the challenge lies. Let me choose my w to be 0 power n, 1, 0 power n. So if you choose w to be this, it is certainly part of this because it's a palindrome. If you read from this, if you read from this, it reads the same. Now simply follow this proof and you see that uv is concentrated on this part. In particular, v contains some number of zeros. So now you see that 0 power n minus k, 0 power k to the power I, 1 followed by 0 power n. Now choose I equals 0. You see that 0 power n minus k, 1, 0 power n is not an L. Because if you read from this side, you see that there will be n minus k, k is at least 1. So which means there will be at most n minus 1 zeros followed by 1. But if you read from the other side, you see that there are n zeros followed by 1. So from left it is at most n minus 1 zeros followed by 1. And from right it is n zeros followed by 1. So clearly there is a mismatch. Okay. And so similar proof technique one can give if x is a even palindrome, x is an odd palindrome, and things like that. So the message is the following. This itself, meaning 0 power n, 1 power n, b power n, a power n, or a power n, b power n, its superset, if you look at it, there are many interesting supersets. There are many interesting supersets which are non-regular. So we can simply use either this itself directly as a string, or a simple fine-tuning to this will help us in solving questions like this. And this is true in general. You solve one problem to be non-regular, that proof technique can be used for many similar problems. And this is one such case study. So the larger message is the following. One has to be careful in choosing W and I. And after that, no control over the decomposition part. So whatever way we decompose, we should show that yes, there exists one I for which we find a string which is not in the language. Fine.